David Hilbert was a brilliant mathematician. He lived in Germany in the late 19th and early 20th centuries. Hilbert loved to think about big ideas. One of the biggest ideas he explored was infinity. Infinity is a tricky concept. It's not a number like 1 or 100. It's the idea of something that never ends. Hilbert wanted to understand how infinity worked, even though it seemed impossible. To explore infinity, Hilbert used thought experiments. These are like stories in your mind. You imagine something impossible in the real world to see what happens. Hilbert's most famous thought experiment is called Hilbert's Hotel. It's a story about a hotel with an infinite number of rooms. Sounds strange, right? That's the point. Hilbert's Hotel helps us understand the strange rules of infinity. In the infinite hotel, even if every room is full, you can always fit in more guests. Let's see how it works. Imagine a hotel. This isn't just any hotel. It's the Grand Hotel, and it has an infinite number of rooms. Each room has a number. Room 1, Room 2, Room 3, and so on, forever. Now imagine that every single room is full. There are no vacancies. Every room has a guest. You might think, well, that's it. The hotel is full. But with infinity, things work a little differently. Hilbert's Hotel might be full, but it can always welcome more guests. Let's see how Hilbert's Hotel manages this seemingly impossible feat. Let's say a new guest arrives at the Grand Hotel. The hotel is already full, but the manager isn't worried. The manager knows how to make space. They simply ask the guest in room 1 to move to room 2. Then they ask the guest in room 2 to move to room 3. They continue this pattern down the line. Every guest moves one room over. Because there are infinitely many rooms, there's always a next room to move into. Now room 1 is empty and the new guest has a place to stay. It doesn't matter if one guest arrives or 100. The manager can always shift the guests to accommodate a finite number of newcomers. But what happens when an infinite number of guests arrive? Section 4. The infinite bus. Countably infinite guests. Now imagine an infinitely long bus pulls up to Hilbert's Grand Hotel. The bus is full of guests and every guest has a numbered seat. This is an example of a countable infinity. You can count the guests one by one, even though the counting never ends. Can the hotel accommodate all these new guests? Surprisingly, yes. The clever manager has a plan. They ask every guest already in the hotel to move to a new room. The guest in room 1 moves to room 2, the guest in room 2 moves to room 4, the guest in room 3 moves to room 6, and so on. Each guest doubles their room number. This process empties all the odd-numbered rooms. Now the manager can easily assign the guests from the infinite bus to the odd-numbered rooms. The guest in bus seat 1 goes to room 1, the guest in bus seat 2 goes to room 3, and so on. Everyone has a room. Section 5. A parking lot of paradoxes, infinite buses, and infinite guests. Let's make things even more interesting. Imagine an infinite number of infinite buses arrive at the already full hotel. Each bus, as before, is packed with an infinite number of guests. Can the hotel handle this seemingly impossible influx? It turns out it can. This is where Hilbert's cleverness really shines. The manager uses a system involving prime numbers. Prime numbers are numbers greater than 1 that are only divisible by 1 in themselves, like 2, 3, 5, 7, 11, and so on. Here's how it works. 1. Existing guests. Each guest already in the hotel, let's say they were in room number n, is assigned a new room number equal to 2 raised to the power of n. So the guest in room 1 goes to 2 to the power of 1, which is room 2. The guest in room 2 goes to 2 to the power of 2, which is room 4. The guest in room 3 goes to 2 to the power of 3, which is room 8, and so on. 2 new guests. Each bus is assigned a different prime number, starting with 3. Bus 1 gets 3, bus 2 gets 5, bus 3 gets 7, etc. Then each guest on each bus is assigned a room number by raising their assigned prime number to the power of their seat number on the bus. For example, the guest in seat 1 on bus 1 with prime number 3 goes to room 3 to the power of 1, which is room 3. The guest in seat 2 on bus 1 goes to room 3 to the power of 2, which is room 9. The guest in seat 1 on bus 2 with prime number 5 goes to room 5 to the power of 1, which is room 5. The guest in seat 2 on bus 2 goes to room 5 to the power of 2, which is room 25. This system ensures that every single guest, whether they were already in the hotel or arrived on one of the infinite buses, has a unique room number. It's a mind-bending solution that highlights the strange and wonderful nature of infinity. Section 6. Countable infinity, Aleph null. Hilbert's Hotel shows us a specific type of infinity called countable infinity, represented by the symbol Aleph null. It means you can pair each item in an infinite set like hotel rooms or bus passengers with a natural number, 1, 2, 3, and so on, even if the counting goes on forever. We've seen how Hilbert's Hotel can handle countable infinities of guests. Even though it seems impossible, there's always a way to make room for more. This leads us to an important question. Are all infinities the same? Section 7. Beyond countable infinity. A glimpse into higher realms. While Hilbert's Hotel elegantly deals with countable infinities, it struggles with larger infinities. Mathematicians have shown that there are, in fact, different sizes of infinity. For example, the infinity of all real numbers, including decimals that go on forever, is larger than the countable infinity we've explored. Hilbert's Hotel, with its countable infinity of rooms, can't accommodate the uncountable infinity of all real numbers. This mind-boggling concept shows that infinity itself has layers of complexity. Hilbert's Hotel, while a fascinating thought experiment, only scratches the surface of the vast and mysterious world of the infinite.